Hey, everybody. We'll get started in a few minutes here. All right. Yeah, I guess Sean, thanks for kickstarting us. Yeah, if we'll give everyone just a few more minutes. We're probably gonna have a lot of people coming in, just a few minutes late. That's pretty normal. But if you want to drop in the chat where you're calling in from, that'd be great. I am currently in San Francisco, California, but I imagine we're gonna have people kind of from all over the place. And we also have Nick from our team who's going to be joining us. He's kind of the Mastra resident RAG expert. So he'll be helping show a bunch of the code samples today. I'll be talking a little bit about RAG. He'll jump in and show us some stuff, and we'll have plenty of time for questions along the way as well. We have some Atlanta, Dallas, Poland, Oregon, Kansas City, Jamaica, Ukraine. I think Nick, you're out near Austin, right, Nick?
Yep. I'm in the Austin, yeah, I'm in the Austin area.
So Daniel, yes, we will I'll send out the link to the GitHub once I hand it over to Nick, I'll send out the link to GitHub. Everyone will get the copy of this recording, and you'll get the link to the repo, you'll get the link to the slides. All that stuff will come in an email, usually a few hours after the event, but I'll also drop it in the chat here in just a little bit. We'll give everyone maybe one more minute just for some of the latecomers to get in, and then we'll go ahead and just get started. All right. Welcome, everybody. Let's get us kicked off here. I will share my screen. It's great to see you all. And for all those that are watching the recording, yeah, thanks for watching the recording. We'll get it started here. Give me 1 second. And yeah, let's go here. All right, hopefully you all can see my screen. let me know. Let me know if not. I will assume everyone can, but I have been known to share the wrong screen from time to time, so that has happened. All right, welcome everybody. So let's talk about what the goal for today is. We're going to learn how to build RAG applications with Mastra. So we're going to go through and talk about a lot of the basics of RAG. Yeah. Okay, one second. All right. Yeah, we're going to go through and talk about a lot of the basics of RAG. Starting at the beginning, we're going to spend some time talking through some of the use cases for it. I'll show some slides, and then we'll actually dig in and you'll get to see some code of how it all actually works within Mastra. Whether you're using it with Mastra or not, you should learn quite a bit just about retrieval augmented generation in general. We're not, the original title of this was, productionizing RAG applications. That's really hard to teach in 1 hour, so I don't think we're going to get fully that far, but hopefully this will be a really good kickstart to your journey. No matter if you're just starting with RAG or if you've been spending a little bit of time with it, you should be able to get quite a bit from this. So some of the things that we're going to learn, we're going to talk about some core RAG or common RAG concepts like chunking, embedding models, retrieval, re-ranking. We'll talk about fine-tuning and a little bit about synthetic data, and then we'll show RAG in Mastra. So who are we? So I am Shane Thomas. I'm founder and chief product officer at Mastra. And formerly, I was in engine product at Gatsby and Netlify. I built a site called AudioFeed, and I've been doing open source stuff for 15 years, way back when Drupal was a thing. I spent quite a bit of time in the Drupal community back in the day. And reach out to me on X or Twitter, whatever you call it these days, and LinkedIn as well. And we also have Nick here, who's going to jump in and kind of show us some code. He's a founding engineer at Mastra. He was, previously at Netlify, and he's excited about RAG, as I think a lot of us are if we're here. So you can reach out and connect with him as well. But let's talk about just high level, what exactly is RAG? So there's kind of two tracks on this diagram, and I just pulled this right from the Mastra homepage because I think it's a pretty good high level diagram of what RAG actually is. So if we look at the bottom part, you have some data, some knowledge base, and you go through this process of putting it through an embedding model. You kind of store it in a vector database, and that's the whole bottom section, right? The whole bottom pipeline. And then you have this more real-time pipeline where someone actually has a query, some kind of prompt maybe. It goes through an embedding model. You do some retrieval, which uses your vector store. You pass that data to an LLM and you get output. And we'll talk a little bit more about this, but that's the general process of how RAG, specifically, using embeddings and vector databases actually works. And I will say one kind of pet peeve about RAG that I do have is, people think of when they hear RAG, they think it's only for vector databases. That's the most common perception of it, but it doesn't have to just be with vector database. If you use a more traditional Postgres database and you do something where you do some kind of retrieval and you pass that information into the context window of an LLM, you're still kind of doing RAG. That's still RAG, but it doesn't just have to be with vector databases. But in this case, we're going to be spending a lot of time on that today, and that's the most common use case. That's what most people think of. So what is RAG? It's kind of what I just described. It's a way for you to get information and pass it into a model so the model can give you better results. One of the problems is if you might have external documents that the large language models are not trained on, and you need to get that information from wherever that documentation is or wherever that data information lives into the context window of an LLM. And this also really helps us get around, context window limitations. Context windows are only so big. There are some really large models like Gemini and other models that allow you to really flood the context window with a lot of information. But sometimes that does, even if you can get it all in the context window, it doesn't always give you the best accuracy. And so being able to have a system where you get just the right results and you can then control how those get passed into the context window can certainly improve accuracy, even latency on some of these things. So that's one of the reasons that RAG is still really relevant and really important today. So let's talk a little bit about chunking. Chunking is the process of you have these big documents. You have all this data. Maybe it's a whole bunch of web pages. Maybe it's a whole bunch of, an internal knowledge base, whatever it might be. But you got to take this information, this content, and you have to break it down into chunks. And then those chunks that eventually be turned into embeddings, and those embeddings to get stored in the actual vector database. But when you do retrieval, you're actually operating on the chunk level. You're doing some kind of query that actually just returns the chunk. So it's really important to think through your chunking strategy and how you want to break up the documents, whether it's, by sentences, by paragraphs, something that's semantically meaningful. So you do kind of have this balance. If you have too large of chunks, you may have unrelated information. If it's too small, you might not have as much context as needed. So you're trying to find that right balance. And this is why it's becomes kind of a very uh, challenging optimization game at higher levels when you're doing RAG, where you actually have to test different chunking strategies. We'll talk about different embedding models, but there's a process where you'll have to spend some time going through this. You do end up storing additional metadata with each chunk, which kind of allows you to help with what semantically similar chunks might be. You can overlap chunks or retrieve neighboring chunks. There's a bunch of different strategies for when you actually do the retrieval part to help make sure that you're getting enough information to actually pass that into the model. When you think about embedding models, so this is kind of the second step, right? First, we do some chunking. Then we take those chunks and we have to actually do the embedding part. All these are just specialized ML models that take your text and turn it into numerical vectors. So just numbers that represent semantic meaning, right? So what this allows you to do, it kind of allows you to do this semantic retrieval or semantic search. So if we were doing keyword-based search, I might be searching for the word puppy, and I would expect naturally that the word dog is similar to the word puppy, but those aren't the same words, right? So if you're doing keyword-based search, it wouldn't return any documents that just use the word dog. But if you use embeddings, those puppy and dog become semantically similar. And so you could retrieve chunks that maybe contain the word dog in it. And so this is what semantic search and why RAG kind of unlocks that and allows that to make your results better when you are passing that information to LLMs. And as I mentioned, there's exact matching, that's keyword-based retrieval. This is how we've been doing search for a very, very long time, right? Then there's semantic search, which is you're using kind of this embedding-based retrieval. And then sometimes you might want to do both. There's kind of a best of both worlds approach where you can do keyword plus semantic search. And maybe you pass a little bit of both into the context window of the LLM. And all of these are retrieval techniques that you might use in a production application. So for re-ranking, often after you retrieve relevant chunks, even with semantic search, you might not get the actual best results first. So you might go through some kind of re-ranking model, which is a specialized model. It's a little more, computationally expensive. So there's increased cost and latency if you add this re-ranking step. But you might do a process where you retrieve the 10 most semantically similar results or chunks. But out of that, actually chunk 5 or 6 maybe is even better for your query. So by running it through this extra process, it'll kind of re-rank those chunks and then pass the best chunks in to your into the LLM to actually get the output. So it's important to kind of think through re-ranking. It's actually one of the first things we see people do when they actually want to productionize and they want to get better quality results is to first increase the amount of chunks you get, which has some drawbacks, but you increase the chunks, and then you can also add this kind of re-ranking step. So it's one of the first things we typically see people do when they're trying to improve the accuracy of their RAG pipelines. Now, the concept of fine tuning is, kind of hotly debated, specifically targeting embedding and re-ranking model fine tuning when you're thinking about RAG. And it can be important when you get into production applications, we're not going to talk about it too much today, but when you get to a very high level of scale and you really care about the accuracy, you may want to then consider taking the data that you do have and improving your embedding model or your re-ranking model through some kind of fine-tuning process. And the reason that could be useful is you may have a specialized use case that the embedding model is not trained on. If you are trying to do some kind of law search and you're looking at like actual legal documents or actual like laws that are passed by the government, maybe the embedding models weren't trained specifically for that task. So by doing some kind of fine tuning, you now can more accurately create embeddings for that specific type of data. So if you have some kind of specialized that's not a general approach, you can really see some good results here, but you do need a decent amount of data. I've heard from different people, it does depend on the use case. I've talked to someone that said with 6,000 basically data set pairs, they could increase the accuracy by quite a few percentage points. And then I've seen others that said it took them 100,000 pieces of data before they really started to see significant results that made it worth it. So it does depend a little bit on the use case. And synthetic data can help here, where if you have some data, you can use the LLMs to generate other similar types of data that can then be used in the fine-tuning process. And with that, let's talk a little bit about Mastra, and then I'll hand it over to Nick to get us started and having us actually look at some code. So Mastra is an open source AI agent framework for TypeScript. It comes with agents that have tools, memory, tracing, has state machine-based workflows that allow you to do human in the loop. We have evals for tracking and measuring AI output. We have storage for RAG pipelines, which is what we're going to talk about today. And we have all of this in a local development playground. With Mastra, our goal is to be opinionated, but flexible. It allows you to get further faster, but we don't want to lock you in. And in the case of something like RAG, this might mean you use Mastra out of the box. By default, you can just start using it and you have a vector database right there. But maybe when you productionize, you want to decide to use Pinecone or some other vector DB. That's fine too. You can easily just swap out those things. So we do have the opinions that get you there faster, but you are flexible enough where you're not locked into our decisions. Really, we like to think of it as like a batteries included. It all is out of the box, but you can, of course, make it suit your needs. So I'm going to hand it over to Nick, and we're going to do a little bit with RAG. We're going to talk about chunking, embedding. We'll talk about retrieval, re-ranking, and then we'll talk about agent tool usage with RAG and what that means. So Nick, I'm going to toss it over to you.
Cool, thanks, Shane. Yeah, let me share my screen and second, cool. All right, perfect. So I want to talk to you guys, but I have a bunch of examples of basically each step for RAG, and just want to go through each of them with you. So we're going to start with chunking, and then I'll show you different types of chunking, like character chunking, there's recursive chunking, there's JSON chunking, and Markdown chunking. Then show you like embedding. So there's different ways you can embed, there's different embedding models you can use. So we can we can see what happens when you do embed and how to embed. After that, I'll show you vector upserting. So just like after you embed, you can upsert that data into your vector DB. After that, I was going to show you guys vector search and then vector re-ranking. So vector, then we're basically querying the vector database and also showing that vector re-ranking. And then we'll tie it off with some examples of using this with agent generation, and that's going to be exciting to show you guys.
And Nick, can you make your code just a touch bigger and maybe
Yeah.
just like hide the sidebar or something so we can, that way,
Oh,
it's just hopefully you all can see it, but maybe make it just a little bigger so
is
everyone
that
can
good?
see it well. Yeah, you can probably, that works for me. If it doesn't for anybody, drop it in the chat and I'll let Nick know. But yeah, that looks good.
Okay, cool. So basically starting off with character chunking. Let me close all these. Basically, character chunking is pretty much the most basic version of chunking. And basically how Mastra does it is we'll create something called an M document. The M document is basically taking whatever document you want to chunk, storing in the M document, and then you can use different chunking strategies to get the exact chunks you want. So for this example, a character chunking strategy would just be looking at the document and specifically splitting on characters. So you would have so for the size of 20, it would look at this text, this is a simple text document that will be split into chunks based on character count. And the chunking strategy is basically very simple. It'll take 20 lines, 20 characters, and then that's the chunk size, and it'll split based on that. And to show you guys that in action, let me do that right now. That's this one. I'll make this one bigger too. Let me do that. Okay, so if you look at here, after we let me make this better. Okay, after we split the chunks, you'll see that each chunk has its own ID, and it contains this various information about the chunk itself. So we have the text, we have a metadata separator, which is basically explains like how chunks would usually be separated. But the most important part is just really the text. So you can see like it splits on the 20 characters where it's like this is a simple text. Then it goes to the text document that will be split into chunk based on character count. And then you could see I logged the exact chunks the chunk text that will be shown afterwards. And yeah, so this is the very basic version of that. Now, if we go to the next example, it's a little more complicated. It's a little more complicated in terms of so this is the cursor chunking strategy, and this one is a little different, where instead of just looking at character length, um, we'll recurse into the content itself and make sure, and it'll try to keep content as semantically close as possible. It'll try to maintain as much as possible use of the text content or text context, and we'll split on separators and make sure that the chunks that themselves are have the context they need. So I do that one. I can do this like here's the chunking. When we split on this code content, you'll see that it tries to keep as much of the context as possible. So it'll print out the function definition. It'll print out some of the comments, and it'll start printing out the some of the code up to the size limit, and then it will go to the next one. But it'll also keep in mind these separators so that things make sense within the context. So like for the example, this last one, it'll keep that whole function together. So as a one chunk. We also open this up a little here. Okay. So the next thing I want to show is the JSON chunking. So basically, Mastra, right now we have different chunking strategies based on your document. So we support JSON formats as well as Markdown formats and HTML formats and various other formats like that. So right now I'm going to show you the JSON format. So we're going to take this JSON content. Oops. We'll take this JSON content and split it. And the JSON content is interesting, or JSON chunking is interesting, because it will not only split into the proper chunks, but it also maintain the nesting format. So you'll see here we have this content will be split appropriately to maintain the nested fields. So you can clearly see that it goes config API endpoint, and then we get all this data, while the other one would be config features, and it maintains this data. That way, when you do split on JSON chunks, you'll still know exactly the order of the content and how it was nested. So it maintains that structure. Okay, then going on to the markdown chunking. So this is pretty similar, but it takes the markdown content, and we have specifically for markdown, we have headers that it'll make sure to split on to keep certain pieces of data together. So I can show you guys that right now. And then, so like right now, we have these markdown chunks, and it's gonna split on the headers it will split on is the pound sign, header one, 2 pound signs, header two, 3 pound signs, header three. So as you'll see, like it'll split, it sees this first line and it'll split on that as it's one of the headers it wants to keep focus on. And then if you go to the next one, it will and it'll say that in its metadata. So for this next chunk, it'll take this part and make this whole section, make this whole part of the section a different chunk. And then if we keep going down, you'll see that basically it's maintaining, depending on the headers you use, it'll try to maintain those, it'll try to maintain those sections as separate chunks to keep all the context together. So that's for chunking. So let me go to embedding now. So now embedding is interesting because there's a lot of different embedding models you can do. And for this example, I've chosen OpenAI and Cohere. Now, OpenAI has a bunch of different embedding models, and the two that I'm showing you are the text embedding 3 small and the text embedding 3 large. The small one is the fastest. It embeds the quickest. It's easier to use for smaller, like if you're trying to do smaller amounts of data, smaller data set sizes, and you just want to worry about quickness. While text embedding 3 large is for if you want higher quality embeddings and you want more accuracy in your queries. And then I also included code here, just show like the different kinds of, you don't have to just use OpenAI, you can use any kind of embedding model you want. And with code here, you have multilingual support. So so when it embeds, it keeps multilingual, the nature of multilingual chunks together. So I can show, and I also have another example for just doing a batch embedding with OpenAI. So I can show you the results of that. If I go to embedding, let me make this more easy to see. So you can see that each one, and granted, what we're embedding is pretty small, so you're not going to see much of a time difference, but you can see the different comparisons in terms of like the output of the different embedding models and their dimensions. So right now we're only putting out the first 5 values, but basically like you can imagine each vector, each embedding will be like, so 1536 dimensions will be basically a length of 1536. So it get pretty long. And then we can see that like when you can do multiple embedding text at once, and each embedding length will be 1536, and you can see how many embeddings you can do at one time. Next I'm going to show you guys vector upserting. So basically we have now, this is where chunking and embedding come into play. So now we have, let me move this over here. Now we have this document that's basically like, it's basically a sample document that just goes over what vector databases are. And now you can see in our example, we make a document. We have the type as markdown as well as our chunking strategy because it's a markdown file. We get the various chunks, and then we generate embeddings for each of those chunks right here. Then we set up a vector database instance. So right now we're using a PG vector to store the vector embeddings. And then we create an index to make it for the vector embeddings. just so it's easier for us to query on it later. So we'll create an index of with the name search examples and a dimension of 1536. And we'll upsert each of those embeddings, including metadata that was found in the chunks. And we'll include the text metadata as well, or the text of the chunk as well in the metadata. So let me show you that right now. So you can see that I successfully upserted 6 embeddings. And basically what that means is that we can use these, and we'll be using this exact data in our next 2 examples. And let me, while we're waiting for that, let me just show you that. So, so the first, this next example is a vector search example. We basically have 2 different searches that we're trying to do. One is just a very basic search with so basically we ask this question: what are the main features of vector databases? We embed that text with an embedding model, and we basically use that to query the vector DB. And then we have a top K of 3. So we only want to return the top 3. It basically means we want to return the top 3 results, and then we'll display those results here. And then also, so I'll explain this first. And then we have another query that this says how to implement vector search. And that's very similar. It's a pretty similar query, except now we're going to filter on the certain metadata inside these embeddings, just to get a more focused answer. So let me try doing that right now. So you can see for the first one, let me also, okay, make this bigger. So for the first response, we're asking what are the main features of vector databases, and we get data back from our from that markdown file that we upserted into the vector DB. So we have the example of values we have is text, type, source, and section. So we get the certain text it gave us, as well as some other information like headers and section info. And these are all this metadata was generated when we upserted into the DB. So we're getting all that info back. And then for the filtered search results, since we're filtering on specific sections, you'll notice that each section, so like while this one has, so like this one will be all focused around this section. So implementation, I mean, all of them are focused on implementation and giving us results based on that. And then, and this continues on to the next example, which is vector re-ranking, which is which basically takes how re-ranking works in this example is we filter and we get some results back from the vector DB. And then we take those results and we take the query we asked and we give it a re-ranking model. And for this example, we're using Cohere re-rank 3.5. And based on the results we get back and the query, it will recalculate the importance of each result we returned. So let me show you that in action. Ranking. Ooh, that's smaller. Okay, cool. So you'll notice first, and I want to focus on the score here. So we have, when we get results back from the vector DB, we'll get a score, which is basically a cosine, it's a similarity score between the query and the different vectors we get back. So we see that our initial results are we have a 0.61, 0.54, and then so on. We have a bunch of different scores for it. But now that we want to re-rank them, we don't want the top 10, we now want the top 3. And we also want to see, we also want to have the re-ranking model change the order depending on which one is most important. So you'll see that we used to have 0.61 as one of our scores, but the way Mastra handles re-ranking is that we'll take the initial vector score, we'll take a position score, which is where that vector was in the last results. Like, so a position of 1 means it was the first in the listing. And then we'll have it do another semantic score check. Basically just checking the text of the data of the vector and the text of the query, and it's basically just confirming that these are semantically similar. And we'll take these values and we'll calculate the new score based on that. So you'll see that we used to have a 0.62, but now we have a 0.59. And it's basically the same for each of one of these re-ranked results, where we'll calculate under the hood what the new score is going to be based on these various values. And basically from there, so that's the basic steps for searching, re-ranking, and upserting. But now we can do now I can show you how this works in a more practical sense. So we can actually move on to doing a dev preview of this. So I have 2 more examples that are basically okay, let me show you that as well. So I have 2 previews that basically do vector searching and re-ranking, but this time we're using tools. So we create we create a basic search tool for our agent to use, and it basically takes everything we've done so far. It'll create an embedding from the query, whatever query a user asks, and it will query the vector store using that embedding, and return results. And the agent will use this tool to come up to format its response. So I'll start with that one first, and we can show this in the Mastra dev right now. So I'm going to open Mastra dev. So this is our dev playground, where it makes it easier to see these various questions in action. So I can go to my basic agent, and I will pull up. Let me move this to my here. So just as an example, I can pull up like an example question to ask it. I can also ask its capabilities, so I'll just do that right now. I'll ask what capabilities it has. And its capabilities are to explore and understand code bases using retrieval augmented generation. And it can perform basic vector searches and to find relevant information. So let's ask it a question about our about certain vector stores. And actually, before I do that, sorry, I'm getting ahead of myself. For the documents that we store in our database, we have I basically have some test documents just to show what we're doing. So this one's like an example JSON application settings document. So it just has different information about JSON settings in the general about that. And then we have one about authentication system guides. So we have a markdown file that just talks about how authentication works, and like OAuth2 works, and how session management works. And then we have a error handling guide that just goes over this different error handling statements. And finally, we have like a logging guide. just breaking down like how logging works and just logger implementation. So these are all just example documents that we fed into our vector DB that we can now query the agent on. So for my first example, I can ask it about the authentication of a JWT in our system, and it will look into the so now it's going to give me a summary of all the information from those markdown files, and just print out different code snippets and just explain just general like how JWT authentication works. Um, so like, and basically because of this, it uses the code that we have available, so it will be able to give a pretty precise answer just based on that documentation. So it's able to go through it and tell me like import required libraries, tells me about some the service class and how to generate tokens and verify tokens, and is able to provide a pretty meaningful explanation as it has access to all the proper documentation. So I can do another example of it for this basic search, and so like I could ask, what are our standard error handling patterns for API responses? And it will look into the error handling documentation and be able to print out this precise information about what we need. And so this is the basic search. So now I can show you, let me go back to the basic search. So this is a basic search tool, and it's pretty powerful, but it does require you to like write this out yourself. And if you want to, it's pretty basic in terms of there is no filtering capability right now, and there's no ability to re-rank. But that's where oh, wait, where a query vector comes into play. So Mastra has a built-in query vector, a query vector query tool that we can use to handle this for you. So it's basically the same as that search tool, except it also has the ability to filter on certain information, and as well as has built-in re-ranking. So you can re-rank your results without needing to personally handle that. So I'll show you how this works as well in practice. So we can switch to this other agent that utilizes it. So we have a query vector agent that is hooked up to the tool, and we can just ask it some questions. So using the same data as before, we can ask it like, well, let me ask also first, let me ask what its capabilities are. So it has has a lot more instructions. So I can query filters, it can use specific tools as information retrieval and is able to explore the code base. And I can ask it now some information about how we handle database errors and validation errors. Let me do that right now. So now it's able to give me precise information just like before, but it's now with our built-in tool. And I can show you this next one, which is basically how filtering works with this tool. So right now I'm not using a filter, or it's not enabled. So if I ask this question, it will look through different parts of our documentation and return it will return information, but it won't give me exactly what the filtering is. So it will show me error handling and auth, which we really only want error handling. So if I enable the filter now, and this allows you to choose if you want to filter or not. So I can ask that same question again. And okay, cool. Let me ask that same question again, now with filtering enabled. Make sure everything works. Wait, reset it. Okay, cool. Now every response it gets is properly filtering our data and making sure that we only want from like from our query. It's we want to filter on error handling. So all the responses are from error handling, and that's working as intended. Um, I think I have time for one more example, so we can show how re-ranking works in this with this tool as well. Let me go ahead and show that to you. So we have a query right here, which is find the most relevant code examples showing JWT token verification and session validation. Um, so now now we have re-ranking turned on. So now it will go through the database, and it does it under the hood. It'll go through the database and fetch results, and it will re-rank to make sure that these are the most appropriate and relevant responses.
So Nick, is this the last example? I did see there's because I get to ask the first question, I saw there was a bonus folder. What's in the bonus folder of
Oh yeah,
the
okay.
repo? I know we talked about it before, but I honestly don't know, so I'm curious.
Okay, yeah, I can show the bonus example.
I mean, maybe real quick. I know we will have some time for questions, but if we can of course just send people there if you think that's more relevant. But if you think we can show it in 5 minutes, that would be pretty cool.
Yeah, we can show it in 5 minutes. Let me show it off then. So basically, I made a bonus section that you can explore in the repo when you get hands on it. It's very similar to the tools we've been looking at so far, except this one is completely focused on how to use this with code. So it's basically a mini, if I had to describe it, would be like a mini like a cursor or a windsurf, where it will take files from these documents. So like I have a bunch of different actual like class documents, like I have an authentication service code file, and then I have error handling that this defines a bunch of different classes and functions, as well as logging. So we have all these set up. And the tool itself will our look through this code base that's been uploaded into the vector DB and be able to provide info and give you information on like give you code snippets, give you examples or functions. And then we have an agent set up just for that. Um, and then giving you examples of each code base. So I can show you that right now. Let me go ahead and set it up in our um, and in the playground. I'm going to do it right now. Um, Here. So now we have a code agent um, that we can use to do specific queries. So I can do this right now. I can ask it to like find the implementation, and we'll compare. We can use this to compare. Here, let me use this to compare this side by side. So we have like different functions in it, like generate, verify, validate, invalidate, and we can use it to ask a specific question to it about like the verify token method. So we can say, find the implementation of the verify token method in our authentication system. And now it will look through the code base that we gave it, and it will provide me the exact code that was in our code base, and then we'll give an explanation of how it's working and what parameters you need, and how it handles different errors. So this is a pretty useful tool. And this is just an example of what the power you have when you use RAG, that you can just give it your code and it will be able to process that code and help you. It's basically a very good assistant to help you look at and explain different parts of your code base. Uh, do you want me to show more examples or?
Yeah, I think that's good. That this has been really cool. Very helpful. So maybe we have about 10 minutes. Maybe we will open it up for questions. Abby, thanks for fielding most of the questions as we went. So I don't think there's a lot in the chat right now to answer. There's a few things. Yes, the recording will be shared. It'll send it out, so that's more of a housekeeping question. You'll get it. It does take a few hours before that email will go out, so in a few hours you should all have it. Is there any other questions though? Feel free to drop them in the chat and we'll stick around for a few minutes and answer any that come in. Okay, so let's see. First question here. So one question is, how can I retrieve data from the Mastra API/stream in a format similar to OpenAI? I assume it's the standard, but I couldn't find it in the docs. So I don't know if I fully understand that. Nick, does that make sense to you?
Retrieve data from the Mastra API format similar to OpenAI. Yeah.
Uh, yeah. All right, we can ask for more information too
Yeah.
if you do
Clarification
need
on that
that.
one. Yeah, I need more clarification on that one. But
Yeah, yeah, Bogdan, if you can provide just a little more clarification, maybe we can help with that. How to deploy to Vercel? There is, yeah, function limits in deploying to Vercel. So we are improving, we have been improving our deployers this week to try to help with some of those things, but it is an issue where, Vercel does have some function limits, and depending on how you set up and what you're using, you might hit those limits depending on your dependencies. So that's just a kind of an ongoing challenge with deploying agents and these kind of AI type applications on serverless environments. But if you are running into issues with Vercel, you should go to master.ai and click on the request access to our cloud and send me an email and I will get you access to see if it works there. Does the create rag tool output Okay, so here's a question from Jeremy. Does the create rag tool output tool get invoked by the LLM, determining it's a tool call to make, or does it get invoked deterministically before the initial prompt is sent to the LLM?
yeah, I was actually gonna tell you my response, but I'll say it in the call. Currently, the LLM determines when a tool call is appropriate to make. And that depends on your query as well as the tool description and its different parameters. So a tool, in order to help the LLM pick the tool most reliably, it's important to have a good description, just a very clear description about what the tool's purpose is. And in your query, it's good to have it's good to like say you wanted to get the weather of a certain location. You want your tool to specifically be about weather information. So you want to say something like, "Oh, just tell me the weather." Like this tool gets the weather for a specific uh, address. And then in your query, you'd want your query to be related to like what's the weather in Austin or what's the weather in New York, and that way that's the most reliable to get the agent to call that tool.
Okay, here's another good question from, I think it's Jean-Pierre, I believe, if I'm pronouncing that correctly. Considering the embeddings correspond to one semantic representation, context/signification, and some chunks might be dense in information and have multiple significations. What are the thoughts about possibly having multiple embedding vectors for a single chunk? I guess, what do we think about that? I have some, general thoughts, but I guess, Nick, anything from you? Otherwise, I can answer this one too.
I guess for questions by multiple embedding vectors, they mean by taking a chunk and embedding it in multiple different ways, or
That's my interpretation. I would say you should experiment with these kind of things. These are good questions to ask. And one of the things I would highly recommend is come up with some kind of evals for judging in a data set for judging retrieval and judging final output. So you kind of have, you got to judge the retrieval, you got to judge the final output, and then you can start to try these different both chunking strategies, but also maybe embedding strategies. Maybe you embed it in multiple ways, and you can pass, you can do multiple retrievals, passing that into context. Of course, all this complexity, a lot of times you're adding all this complexity for very little gain, and you increase cost and latency. So those are all things you should really be thinking through as you're making those decisions. But I don't have any strong indication that that would make it better. I think it would be use case dependent, but it's certainly something you could consider trying. So is chunking necessary? I have distinct entities in my database, but they seem short enough to be sent to the embedding model directly without the chunking step. What do you think, Nick?
It really does depend on your use case. But I would, if they're short enough, yeah, it depends on your use case and what kind of embedding model you want to use. If it's small enough you don't feel like you need chunking, then that would be fine. But you probably want it if it's long enough where retrieval becomes inefficient, then you probably want to consider chunking because you don't want the chunks to be too big, or you don't want the text to be too big when you embed it. So then it makes it hard for the tool or the agent or however you want to query the vector DB to properly get your proper info.
Yeah, and related to that, one thing that often see people do is kind of a little bit more of an advanced drag strategy is you not only just get especially if you do have chunking strategies and you do end up chunking, you not only get that chunk, but you might get the nearest neighbors to that chunk. Because if you think about something, how we would search a document, if we only get one paragraph, it's actually kind of nice to have the paragraph maybe before and after so you can kind of get more of the context of what that actual paragraph means. It's kind of hard if you just have that one paragraph. So a little bit related to that question, but that's a good question. Um, so
Add
any
something?
thoughts on, oh, go ahead, Nick.
No, it's the
Oh,
big
Avi,
brother.
go ahead,
Um,
Avi.
so we are really good friends with this company called Raggy, and they do RAG as a service. And when we talk to them about just chunking strategies, and they do multiple chunking strategies because they cannot determine. Imagine, right? If you're running RAG as a service and you're doing this for other people, you don't know what the documents are. You don't know anything. So, like, I mean, truly, you don't know anything about the customer's documents, right? So they do like 10 strategies and then they like will cycle through them to get the best result. So to that question about should you do multiple? Yeah, maybe. Like if you truly don't know the source, like maybe you should do different strategies just to shore up, like be careful about or like cross all the dots and shit. Um, but if you do know what you're getting into, then you should make more like defined strategies. So yeah, okay. Thank you.
Yeah, yeah, good answer. Okay, any thoughts on GraphRag with Mastra, Nick?
So we actually do have a GraphRag implementation with Mastra. So it's in its separate tool as well. So you can use a create GraphRag tool and get a lot of good functionality out of GraphRag. And for people who don't know what GraphRag is, it's basically a more it's a good way to keep connections between different vectors possible. So what it will do is it creates a graph of information where when you insert information into a DB, not only are you storing that info, but you're storing info and connections between different parts of different pieces of data. So like if two pieces of data are connected in some way, and you want to maintain that connection. So whenever you grab a certain piece of info and you got five different connections, and you want to know that those are all related, it will fetch the data you want and will fetch pieces of data that are connected to it and be able to better explain the different connections. So it's pretty useful, and we have a implementation currently.
Cool. Yeah, continuing on, we got a lot of good questions. So we'll answer a few more. We might not get to them all, but I will say if you do have more questions about this stuff, you should come to our Discord, ask them in Discord. We'll follow up after the fact and try to answer them and work with you if you do have, more specific questions as you dig into actually trying this stuff out. So that's kind of the plug for the Discord. And actually, I'll share my screen just to kind of wrap this up. But there's a couple more questions here that we will take if we can get a couple more done. So give me 1 second here. I guess while I do this, let's maybe, how would you work to future proof in terms of the embedding vectors, considering embedding models will evolve over time and our database will grow over time?
Hmm, that's a great question.
Yeah, I mean, I would say, go ahead.
I could take- So we will work on this incremental, like, wait, so when we worked at Gatsby, we built these incremental builds, right? Where you only build the part of the graph that changes. Now that's on our roadmap, and like that's the dream of this, right? You're only changing the things that change over time. So like your embedding models, as they get better, like yeah, if the embedding model gets better, you have to re-index. Like that's just the truth, right? You have to re-index your data. That sucks, but like it's the truth. But if you're re-indexing data and you only change part of your graph, you only want to re-change that part, right? You don't want to spend the money, the time, etc., re-indexing everything. It's not easy to just re-index parts of your graph right now. That's a big problem. That's a big money problem, actually, if you think about it. And so we want to do that. But and like embedding models are going to get better. People are going to fine-tune embedding models. You are going to re-index your data. That's 100% certainty. So if you don't like that, I mean, just look in the mirror and accept it today. But you want to incrementally index the things within the same model and the same parameters. You want to re-index only the parts of this thing that change. So I don't know if that helps, but that's just the truth.
Yes, thank you. All right, so we do have a few more questions. We are at time though, so I'm just going to do a few quick plugs. If you're still here, please go star us on GitHub if you haven't already. We would appreciate that. It helps more people find us. If you're interested in trying out our cloud product, go to the website and click on request access or go to this and just join the wait list. We're slowly rolling out our cloud product to multiple people and we want to get feedback. So you can connect with me or Nick on Twitter or me on LinkedIn. Here's all the links. Thank you all for attending. You will get this in your inbox in a few hours. And if you didn't get your question answered, apologize, we ran out of time. Please drop into our Discord and we will help answer those questions. Thanks everyone for attending and yeah, have a great rest of your day.
Hey, everybody.
Yes, thank you guys. Thanks a lot.
Thank you. Bye.